Okay. Hello, people who are probably going to watch the VOD, and anyone here. Thanks for joining. Today, what am I going to work on? So, we're going to check out some Lambda CPU questions. Yan Shui was asking me about how much CPU you get in Lambda, and I want to be able to answer that. I also want to do more of this. Hey, Adi Super, thanks for chiming in. Joining chat, appreciate it. We're going to look at some Lambda CPU investigation today. I want to review the work Michael Hart has done and see if it still holds. He did this thing a long time ago to figure out how much CPU you get. I also brought the Kinesis Advantage 360 home with me again today, so I'm going to set up the webcam with the phone and see if we can get a shot of that. Might be hard with the boom here. I gotta think about this a little bit. We'll see. Let's try and get this going live here. Hope everyone's doing all right. Yeah, I guess the boom arm is gonna be really annoying. Oh, that is not going to be comfortable for me. Okay. Let's see what we got here. That looks okay. I just can't sit at my desk. Oopsies. Okay, this might work. We'll see how long I can make this work, because I'm tucked up with a tripod here. Okay, cool. Yeah, this is the Advantage 360, and I gotta get the focus right here. What is it auto-focused on? Okay, a little better. Cool. How we doing? Okay. Oh, all right. Oh, geez, I just knocked it again. There. Okay, that's not so bad. Try not to hit it with my elbow. No promises. Go back to me for a sec. Okay. Couple things I want to do. The first thing I think I want to do is start looking at Lambda CPU. So how do I go back to Firefox? Okay, perfect. Michael wrote this post a long time ago, 4 years ago. Sorry, Michael, not that long ago. Called shave 99.93% off your Lambda bill with this one weird trick. And the cool thing about this post is that in theory, it would sort of work. And the idea is basically Michael noticed that the initialization period of a Lambda function gets it more CPU, and you don't get billed for it for managed runtimes today. So for managed runtimes today, you don't get billed. And he wrote this little handler code which creates these PBKD2F hashes, password hashes, and he just does like cycles of them per second. And then he was testing them out in Lambda and was showing that in the init phase, he was getting 12.37 or whatever, 334 hashes per second. And then in the handler, he was getting something similar when he was at 3,000 3 gig, which at the time was the max. And then he noticed that when he went to 128 megabytes, he was still able to get that like 12 and a half hashes per second, or 12 and a quarter hashes per second. But he noticed that he was able to get even far less during the handler, when the handler was actually running, which is of course like indicating that they give you more vCPU when the handler is initializing versus when it's actually running when you have lower memory. So I want to just run this again. So let's do this. We got to announce this on the internet that we're live. All right. Post this here. Boom, boom, boom. What else should we talk about? New blog post? Yeah. Boom, 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 boom. Hell yeah. Okay. Sweet. Okay. We did it, team. Hope folks are doing all right. Yeah, okay. So what do we got? Yeah. Okay. So I recreated a couple of these. Whoopsies. This was the easiest one to recreate, right? I just basically copy the code out off of his blog post. So require the hash function from the crypto library, require fs, and I was doing that for a specific reason I'll show you in a second. And then give it a deadline, and I think I was giving it 2 seconds. Calculate a bunch of hashes, and then it would, this is just like the method we use. We'd call it during init, which is outside of the handler here on line 15. And we would do that for 2 seconds. And then I would call it during runtime, the Lambda handler, for 2 seconds. But then I added something new to Michael's blog post. And what I did was I added a file read, and I was reading proc CPU info. If you haven't looked at proc CPU info in your Linux system, I don't know about OS X or Mac. If you haven't looked before, this contains all the information about all the CPUs and cores that your system has available, and then what's most important is that it also includes what percentage utilized they are, so we can get kind of like a bit of a metric information from there. And then it was returning all of this. So I want to make sure this is still up. Okay, we'll get that out there. In the meantime, oh, oops. In the meantime, I'm going to fix this thing real quick. Let's see what we got. Is Michael essentially telling us to squeeze more work in the init phase? Yeah, exactly, Adi. That's exactly what Michael's suggesting, is that you can save a ton of money by just in the init phase doing all of this work that you were going to have to do anyway, basically. And I think that's kind of cool. I think that's a neat concept. I don't think it really works that well because you don't have an event, but you could make your own router. There's a couple people on the internet who've made their own Lambda routers, and effectively they host a task in Fargate. That task then, oopsies, here we'll do this. That task then will pull work off of a queue or like receive requests, like act as a proxy. And then we'll route that to Lambda with a direct invoke in batches. And you can kind of do work that way, which you'd be able to kind of take advantage of the init phase thing here, which you wouldn't be able to do necessarily any other way. But if you're just calculating hashes, then yeah, you can totally do this. Okay, so let's, oopsies. I think I missed the end of Milky's stream by like 2 minutes, and this laptop had to restart. Okay, that looks good. Adi said, "What? Oh yeah, what if AWS starts billing the interface?" I think they will. I mean, they're right now. The docs say they do bill. So like, if you look like Lambda billing, so duration charges apply to the code that runs in the handler of the function, as well as initialization code declared outside the handler. Period. So that's it. They say they do. They don't yet. And I think it would be a painful thing for them to try and roll out, but they say they do. So I'm waiting for the day when that will happen. In theory, it's coming, right? Like, otherwise, why would they publish the fact that this, like, why would they state this? And it does happen for container images and does happen for custom runtimes. So, although I think container images shouldn't charge that, because now with their caching strategy, I think it's a lot cheaper to run. Anyway, okay, what do we got? A lot of information. Okay, this is cool. Okay, so in the init phase, we got 15 hashes per second. But then in the handler phase, in a 128 megabyte Lambda function, we had 1.19. So I think Michael's research is still pretty solid. I think it still holds. But something interesting is happening in the CPU info, and it's super hard to read. So should we could cat that through JQ, or we could, yeah, I want to, oh, it's tab delimited. JQ wouldn't even matter. Oh man, I wonder what it looks like in CloudWatch. 1 second, we're just gonna go secret mode quick, 2 seconds. Log into my AWS account. Oh, that's right, I can use my fingerprint. I was like, okay. Oh, shoot, I need to MFA and my phone is acting as a, my phone's acting as a camera right now. Okay, how are we gonna do this? This will work. This is gonna work. We did it, chat. We're in. And did I disturb the camera too much? Ah, not too bad. Okay. This is my new tech beverage of choice. This is a Poppy, and it's got only a little sugar, but it's got this probiotics in it, which is all, I think, just apple cider vinegar. I think that's the big ad of this one. Okay. Am I sponsored yet? No. I have my first subscription, though, which is pretty exciting stuff. I'm not trying to make any money on this. I'm doing this because I would do this anyway, and it's fun to hang out with everybody here. Trying to figure out how to grow this, but that's going to be just hard, as I'm expecting a baby soon, and I don't think I'm going to work that much on Twitch. But I want to keep hanging out like this. It's good. All right, what do we call this? We called it just Node 128 dev. Hello. Okay. Boom, 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 boom. Is this going to be pretty printed? This is the real question. Oh, no. Of course it's not going to be pretty printed. Oh, there it is. Okay. Sweet. So I think what we can do is split this on new line. So what it's saying here's processor 1, processor 0, CPU ID level 16. Oh, I think it's proc CPU info. Shoot. Yeah, this is a Mac, so it won't have that. Oh, we can. Okay, so let's just jump into. Oh, fine. We'll start Docker. I've been trying to replace this with Finch, but Finch is not standard at my company, so I end up spending all my time in Docker anyway. Okay, let's try this. Jump into this. CPU info, okay. I thought I could get the percentage busy from proc. Because these are all the file descriptors for this process. Oh, I wonder if that's what I have to do. I have to look at the processes that are running. Let's add, there's one thing that I can ask. Well, that's Perplexity. On a Linux system using proc, how can... Proc stat. Really? Does this exist? Hey, it does exist. Okay, let's do that. Thank you, Perplexity. Okay, so we don't want CPU info. Well, we know, okay, so what we know is we have 2 cores. We're on 128 meg. Has 2 cores. Same processor ID, PID 0. Physical ID, I'm sorry. And then CPU cores 2, and that's core ID 1, and the other one is 0. So you 1 processor, 2 cores. I wonder what we're gonna get on this threshold. And I don't know. It'll be tricky with Node to get a read here, because this is like I'll have to read the file while it's being utilized. But let's just see what we get. Okay, I just want to see what we get. You got to start somewhere, right? Oh, and we should tweet that. We should tweet this. This is good. Good result to have early in the stream. Thanks for Michael for doing all the work so I could just copy and paste it. Hey, Amor. Great to see you. Welcome back to the stream. Thanks for stopping by. What are these PBKFDs? Is that the name of it? We'll just, you know what? Okay. Oh, I gotta tag Jan in this too. Cool. Awesome. Okay, that is done deploying. Hit that endpoint. What do we get? Come on, do those hashes. Hope everyone's doing all right. Okay, 2 CPUs, and I think what is the output of CPU stat? No, there should be 2 here, yeah. We just got to split this on new lines. What am I doing here? What the? Okay. What is this? It's /n. You know what? I don't even need to write. I'll just do this manually. Yeah, so 2 CPUs. Here we go. So what I want is a process. So okay, this might be tricky. How are we gonna do this in Node? Because I'm not using the event loop. So when I'm creating these hashes, I need something that can read this file while these hashes are being created. I may need a Lambda extension for this. Because like the code, my hash generation is stopped by the time this code runs, of course. And I don't know when this is updated. Okay, what is this format? We get user nice system idle IO8 interrupt soft interrupt, and then total time minus idle. Okay, so it's just everything minus idle. Okay, so what do we get? Let's just draw this out so I know this. So this is 0. Okay, and what do we have here? Whoa, not trying to use the mouse to edit my code, man. Okay, first column, user, nice. I'm gonna have to get some space here. Oh, and that's a summary. Okay, that's good to know. Okay. Idle, that's what we want. Okay, so we add everything up, we get idle. Yeah, and that's why this is going to be super low. Is Perplexity hallucinating? Are we right? Is this correct? Did it cite its source? Let's Google and see what stack. Oh, here we go. Linux how-tos. It's probably right. 99% chance it's right. User nice system idle IO8. Yeah, okay. We did it. So 2 problems we have to solve if we want to do this. The first is, how are we going to read this file while the CPU is occupied? Because Node isn't going to let me kind of run 2 things concurrently unless I start using the multi-threading module or whatever, like creating actual threads. And Python would let me. I could use Python's multiprocessing or a Lambda extension, which can read the same CPU. The Lambda extension might be the way to go. That honestly might be just the ticket we need. But I would want to write it in Rust, and that will take forever. I could write it in Go probably pretty quickly. We do have Copilot. But I want to do it in Rust because I'm trying to learn Rust. Okay, so we know what we need, right? We gotta add all these up, and then we have to subtract the idle. And I think Perplexity is pretty solid there, right? Like that's the algorithm. Yeah. So try and just get that working, and let's try to I don't think I can handle the interrupt in Node. Like, I'm sorry, not handle the interrupt. I don't think I could make that read during Node, but does it matter because it's like a total time over a period of time? So maybe it doesn't matter. It's aggregated. Yeah, Adi, I'm just trying to get a rough estimate of the CPU usage. Let's just implement this in user code and see what we get. Okay, so we need to write this as, oh, I shouldn't have done that. Okay, and I need to go back to the string. Okay, this is the string we're gonna get. And vim output, okay. Okay, Bum, 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 bum. Read until the new line. Split space. We've got 2 here. Okay, so let's just do this in oopsies. Let's leave Docker. And let's open up a node console. Okay. So that's good. Now we've got these. This is where we could use some map and reduce. Okay. This is over all cores. Do we want, but we should probably output both separately. I don't think we want the aggregate value across all cores. You got Perl code that runs this for your i3 block. I'm not trying to touch any cursed Perl code, man. I started my career in Perl. I'm not trying to $_ my way out of this problem. You can share it if you want, though. What are all these columns again? What do we got here? Total time is just sum it all up. Okay. Then it should be empty, empty. Okay. Okay, this is easy enough. So the columns is equal to that value. Bum, bum, bum. Calls equals this. Okay. I forgot Python, we just do this. Does that anything? Yeah, it's not anything. How do we get the remaining elements from a array in JavaScript? I forget. Oh, you know what? Why am I not? That doesn't look like the code to actually read the file. It just looks like what parses the output. And I don't even see where you parse the, because you just say CPU usage equals -1. Ah, there it is. I don't know. Do we have MP stat? We can try that too. Oh, yo, crazy for real. Thank you for the follow. Yeah, why don't I Google this instead? I should have Googled like how can I get the CPU on a Linux system? Yeah. I don't know what'll be in Lambda though. Probably not much. This is okay. I think we can do this, right? We know how. We've already got most of it. You know, for I equals 0, or we can do what, 2, right? I is less than calls.length. Oopsies, why is it? It's not a, come on. I plus plus total plus. Oh yeah, we didn't. Oh, here, well, 1 second. Let total in the for loop. Calls I total plus equals calls I. Okay. Undefined. Shoot. Oh, and it's just slapping the string together, of course. That's close. Perl looks like something I wouldn't want to touch. It's not that bad, actually. Modern Perl, I can't complain too much about. Pushing is just going to append the string. Regalias, thanks for joining, man. I need to cast it as a number. That's the first thing. But why is... We're starting at 2. Why is the first one undefined? Let's try this again. And then this should be number. What? Oh, That looks a little better. Is that right? 271 plus 81 plus 59. What was that? 460. Oopsie, 60. I hit the mod key. Oopsie, nope, too many numbers. Plus 2 plus 5 plus 28. Yeah, we did it. Yeah, that's fine. Okay. Yeah, that's easy enough to do. Let's just read that file. Okay, time to implement it. Let's bring our string here. Okay. Const get CPU stats. Whoa, Copilot. Okay, that's not bad, but we need to parse it too. And I don't need to log it. Oh my god. What should we call it? What do we want to call it? Get CPU. Get CPU percent. Thanks, Copilot, for filling that. Copilot helpfully filled in this. Oh, let's go, Copilot. That looks pretty good, doesn't it? Okay. Here we go. And this is CPU info 0, which we don't really want that. We want to do this over the other two CPUs. Pretty good though. It got at least this part for me. Although I don't need... Why do you need to reduce? Okay, that's not quite right, because idle is a number we should just pull out. It should literally just be like the 4th index, right? It shouldn't need to slice or sum anything up. Let's see what the code does. Okay, that's fine. Calls dot slice 1. This should be not 1, it should be 2. That slice was what I was looking for. Okay. Okay, perfect. So that's fine. That works just fine. So first we want slice 2. And I don't want the rest of this because that will give me, that's not idle. CPU idle is just that one number. CPU idle is 0. Should be 4th column. Okay. Yeah. Boop. 4. Wow, we're really gonna do Copilot. We're really gonna do this. We would need this as a number. And I don't need to split the whole CPU info here because I can do that in another method. So let's assume it's split. Yeah, and then we get the row. So we can do stats dot split. Okay, so this is gonna give me, this should give me, given a row, get CPU percentage, and then give it a row. Oopsies. What do we name this? Input string. Oh yeah, okay. It should just be input string dot split, and then we'll give it 0. Yeah. So you move it not at 5. What did I do wrong? Oh, it doesn't like the number. Oh yeah, oops. that should have gotten caught. Oh, it is caught. I just didn't read it. Okay, try that again. Okay, input string. Looks good. Okay, so we don't need to split. We just want that. Okay, perfect. Get CPU percentage, input. Not a number. What did I do? Chat, you were supposed to solve this for me. Oh, chat, I'm sorry. I'm cutting this off. Hopefully that wasn't, I mean, maybe that just annoys me. Oh no, I've got 5 notifications. What did I say? Michael, I can't, you better be in chat, Michael. I can't believe you. I'm yelling at Michael Hart to help me out. All right. I need a little bit more volume on this chill hop. Actually, this might not even be the vibe right now. What is on this playlist? Any of this good? All right, we'll do this for a minute. If we don't like it, chat, we'll switch it. Jump to code. Yeah, sorry. You're right. Oh, I think I know what's happening. There's an easy way to solve this though. Stats here. So this is, yeah, well that obviously wouldn't work because I didn't split it. So we want to do this. Stats equals input string dot split new line. Still getting used to the keyboard. It's a little harder on the coding stuff. There we go. Get CPU percentage stats. Not a number. Okay. So let's figure this out. Stats dot split space dot slice 2 dot reduce and then accumulate. I don't really care about, I guess, yeah, if this fails. Yeah. Oh, it started at 0. Never mind. Okay. That looks right. Oh, number is not, this is wrong. Oh, yeah, that's way wrong. Okay. So, my code is just bad. Oopsies. I don't care about this. No. There we go. Okay. We don't need stats 0 because stats is already split. And I guess we could split stats once. Yeah, let's do this, and let's call this. Oopsies, not escape. And then we don't need, oopsies, get that, there. Simple, clear, effective software. This is what I should have done in the first place instead of goofing around. And that's okay. Okay. Okay, and we can redeclare this. Perfect. Okay. Get CPU percentage stats. Hey, 99% idle. Right, because... Oh, no, that's not right. Oh, that is 80. Wait, is that? Oh, no, hold on. Did I do this right? Whoopsies. No, I did not do this right. Okay, so we need to do the first. Okay, the first things first. We're splitting, but then we just need to spread because we don't care about the first 2 items. Stats. So stats dot slice 2. No, that won't work. Yeah, and then the fourth 0, 1, 2, 2 the third item. Okay, so I want to refactor this. Dot slice. This is all wrong. 2. So now we just should have this. Whoopsies. I think you know where I'm going with. Yeah, of course. We're going the right direction. We're going to space. Anyone going to watch the eclipse this week? Anyone in the US going to do that? Okay, I'm feeling this now. Some hacky JavaScript. So we should have, oopsies, we should have this now, which is good. And the third item is idle. And we don't need this slice anymore. Okay. I know it's never read. Relax. For better or for worse, I do a lot of hacking around in the console this way. Okay. There we go. I thought you were trying to say CF worker style building is beneficial for most use cases. Yeah, I mean, I think it is probably. It depends what it's doing. I think that's going to really vary off the API use case and into the async data processing. Like workers is going to always be, workers is very much going to be, I shouldn't say always, very much going to be an API driven product, which is great. It's a great thing. But one of the things Lambda is so good at is reading a ton of data. Adi, how am I going to run this in parallel with the other bit of code? That's the question. I don't know the answer to that yet. My best, I guess my best guess is I'm going to either write a Lambda extension that will wake up every 10 milliseconds and get the output and then average that for the run, or use Python instead of Node and make Copilot chat convert this script and use Python instead of Node and then have it output the value, if that makes sense. But yeah, I don't know. I don't know exactly when, like how often proc stat is updated. And I think that's the real question is like, is there like a time window? Is it just whatever the current is, like a snapshot read? What we could look at is a profiler, which would be able to tell me, it would be able to like attach to the process and tell me what exactly the CPU is doing at any point. Yeah, Rafa has a good idea. Lambda exec wrapper to run the node process in another in the background. That could work. But at that point, then I'm beholden to the scheduler. But if there's 2 cores, I should be able to steal enough cycles to like read that and figure out what's going on. But what I kind of want to do first is just get this out here, because like yeah, we could do a Lambda exec wrapper and we could just fork a process and start another node process. That's pretty easy to do. I think effectively that's like I think if we look Lambda internal extensions, I think that's just what that is. Yeah. I'm just harassing Michael Hart on Twitter. Sorry. Yeah, update on every access. You see the state of the kernel in the moment. That's why it's shown for size. It's not real size. Okay, so we have to run it at the same time if we want to go this route. That's fine. We can do that. First things first, though, let's just get this printing, right? Like, let's figure this out for both CPUs, get that printing. That's the first step. Do we want to look at the keyboard again for a minute? I guess if we're going to code, we probably want to look at the keyboard. Oh no, did some cable loose or something? That's not good. Uh-oh, there it went. One sec. We brought it back. We smashed the cable out of the keyboard or out of the phone. Okay. I don't know why it's flickering. That's super annoying. All right. What do we got? Okay, so this is working. That's great. We just have to give it the input string. We have to give it one CPU at a time. So okay. This doesn't need to be a method. CPU info dot split n, and then we need dot slice. I think we don't want the first one. So 1 to 3, I think is right. Input string dot split and oopsies dot slice 2 3. Nope. There we go. 1 3. Yeah, that's right. Wait, we were right. Chat, we were right. Okay. There we go. Copilot, thank you. Okay. Actually, you know what? Let's destructure this. CPU info 0. CPU info 1 equals that. And then we'll do the same thing. Actually, raw CPU. Boom, boom, boom. Oh, but we might have more than... Okay, when we get up to 10 gigs, this won't work, right? Because we're going to get more CPU. I think it gets up to 6 last time I tried this, but let's find out. Yeah, what are we doing? What are we doing here? The whole theme of this stream is ship it to prod. Let's get it to prod. All right, CloudFormation. We did it. 40% faster CloudFormation. What do you think? Internal server error, or is it going to work? Copilot helped us here. Oh, look at that. 199. So it's almost completely idle, of course. Doesn't really feel 40% faster. No, it does not. No, it does not. All right, this is perfect. So we've got 2 idle cores here. So first, let's okay. What was in that string again? So I think what we want to do is throw away, count the number of CPUs we get, throw away the first one. Okay. So our input string array looks like this. Oh. CPUs. And we do need to pass the info. So this is what we get right now. We don't want this, we don't want this, but we do want this. Then 4 row of CPU info. If row starts in there, we go. Hey, you did it, Copilot. You were there. We'll just create a little struct here. I know you TypeScript nerds would tell me this could be a thing, but you know what I'm saying. It's a little hash, little hash map. I think that'll work. I know. Okay. Man, coding on stream will give you serious serious imposter syndrome, because I feel so bad. I can't just do this as fast as Copilot does. That's okay. Oopsies. At least it keeps you motivated to get shit done. I mean, I'm pretty intrinsically motivated to get shit done. Appreciate it though. Oh, it didn't return anything. Nerds. Can't believe I did that. Oopsies. What do we call it? Stats? Yeah. That's not right. Oh, because I did define this wrong. Oh, no, that's right. Oh, no, it's not. I did that wrong. I put the parse one in, that's why. Stats string equals. There we go. Nope, it's still wrong. Let's just do this. Split it again. I don't think Node cares, does it? Oh, it does. Oh, that's what we're doing wrong. Oh, we got a library that does this. That's cool. I'm not going to use it, though. I appreciate you. There we go. We're chilling. We're chilling. We did this. Look at this. Go team. All right. We'll take a look at Oscopus. Maybe they've got code we should use. Half the journey is just slamming this all out ourselves. Half the fun. Oh, look at that. Built in. Of course it is. That's fine. I appreciate it. I should have looked. I'm sure it's in node going back. Yeah, node going back to 6, like V0. Like anything would do this. I knew it existed. I just didn't even like. I wanted to goof around with proc stats. Well, at least this confirms ours is working. User nice sys idle IRQ. That is not quite what we see, right? IO wait. Yeah, I mean we can look at node. Whoa, look at all this horsepower. Well, I guess we should use it. That's the right answer. The correct answer is not to use any of this. That's fine. Const OS equal require OS. But it was fun, and at least we were right about our parsing. That's cool. Yeah, I knew it would exist. I was like intentionally trying to not go and find it and try and mess around with it on my own. I'm sure any Linux proc directory, like any of the network information, is all well libraried up. Oh, it doesn't tell me the core, though. I guess you can just count them. Doesn't really matter. But in, I think I was hoping it would tell me if this was the efficiency core or the performance core. Because there's that core information, right? That Macs have? I guess it doesn't. That's too bad. Well, this still doesn't matter because we can rip through the times. Okay. os.cpu.map core. Is it reduce, and then you have a cum. Oh, they're named though. Yeah, that won't. So we want to do that. Wait, undefined. Oh. Okay. That looks good. How do I want to do this? Okay. So we've just got one of these little guys. Core times equal Is it I forget the syntax for this. Chat, help me out. Oh, that's the number. That's not what we want. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so at least it gets a CPU number. Oh, is it? Whoa. What if I don't? If I don't destructure the array? Is this different? Oh no. Yeah. So I can just push the number on, get the key, and then the value is that hash. And then for each item in the hash, we can just add them up again and then divide. That seems fine. We've got all these, and then we can do time. Oh, we don't even have to remap it. We can just do this in here, can't we? Bum. This might be easier to do in an editor. Could do this with map and reduce, but it seems like a little easier to do this. What do I do? Whoa. No, this isn't right. Okay, Copilot, you tried. That looks a little better. Oh, of course we didn't return. Uh-oh, that isn't right. What did we do wrong? Bum. Copilot failing me again. That's fine. Oh, right, because it's one model. We don't want the model, though. So we should do a different loop. We should do for const CPU ID. Then we should do object.entries. How's everyone else doing as we hack through this? Everyone's still hanging in there? That looks pretty good. All right. No, that's not what I want to do. Get all CPU. Nope. That's fine. Nerd tree is, or is it nerd tree or tree sitter that's fighting with my copilot right now? Okay. Give this a rip. Everyone hanging in there? Chat, you doing all right? Folks still sticking around? Seeing if this works. Yeah, node wrapper is going to be the answer here. I think that's the path. Or just like, yeah, an extension and then publish it up as a layer, which is fine too. The problem is I can't. So I got to store this somewhere else then. So it should be completely idle because it's the CPU's done at this point, which is fine. Why do I have 3 CPUs? 4 CPUs? Doesn't make any sense. That wasn't what we saw on proc. Okay, we can delete this. Okay, let's see what we actually have here, because I think, why does Node see more CPUs than we saw? Right, because we looked at Proxys and we only have 2 here, 2 cores. And my code just returned 4. It's got to be my logic. Wow. All right, let's see what the logs say. All right, we just curled that endpoint. I'm going to go back to Firefox. Yeah, I did something wrong. There's something very wrong. My logic is broken. Okay, let's fix this. Oh wait. What? What? That doesn't make any sense. Why did it return 2 more cores a second ago? Oh my god. Okay, well. Does Lambda rotate cores by usage? I mean, that would be a very interesting finding. I don't think so. Oh, sorry. I didn't even show you guys this. Check this out. So the very first time we ran this, we got 4 cores. And I didn't change the code. And now we got 2 cores. So I thought there was a coding mistake. But I'm logging it now. So let's see if we can see something like that again. That's very interesting. Weird. Yeah, we got the 2 there. So the problem, so what I want to do something here. So the idea for this project is like, I want to list a ton of these Lambda functions. Grab one of you. And I want kind of like a whole grip of these, right? I want to do 1 in 128, you know, 1 256, etc., etc. And I want to put these in a test bed, and I want to figure out what CPU they get during init and during the runtime phase. And I want to run it over a period of time, like months, basically. And I want a dashboard to reflect this. But what I most importantly want to do is the question now is, how do I get this data back? Because I need to do some hashing. I need to do some CPU work. And then I need to report what was going on. And that means I have to send it to some third party. Because we can easily do this with Datadog, but I think that's less interesting to like just plug it in off the shelf and show you folks. I think it's way more interesting to build like this thing for everyone. The problem is twofold. One, we need something outside of the process to, like, we need one process generating a bunch of crap, and then we need one process that's reading the data. So I think what I have to do is actually fork. Either we do an extension, which is great. The problem is that the extension, we could do the proxy technique and modify the response. Oh, okay. Maybe that's the path. Maybe, okay. Will that work? That would work. We would have to, what we have to do. We have to run an HTTP proxy in Node to proxy the request and response, which is doable. Oh, but Node's just going to wait. We'd want to... So I think what we could do, would this work? Let's think about this. So we have this Lambda function, right? We have this like request. Request comes in. Now, this is a function. What if we did this? What if we did, okay, so it hits my extension. And we're going to do we can do a proxy. So we can actually run reverse proxy, and then while true, add CPU. And then this can push the data to the actual function, right? And then on the way back out, this will return. Whoa, I don't want that. So this returns, once that function returns the hashes that we already have, the hashes per second, and then the number of hashes it calculated. Oh God, the Mac camera thing is doing this thing for me. I forgot it does this. How does it? Yeah, there we go. Sweet. Then when it sends it back, we could modify the envelope. We could open up the envelope and stick in the average data and then return it to me. And then we could store that somewhere else. Does that make sense? Lambda has this like proxy option you could do now, which is kind of neat. I think maybe that's the path. Oh, what's up, YouTube? I haven't been in chat over there. I should have. I'm sorry. I tried to look. So I think that would work. I think that would work. We'd probably want to write this in something like Go, like this extension in Go, and then like that way it'll have as little overhead and impact like that process on the running CPU as it could, or even like Rust, ideally Rust. So it's just sitting there polling on that file and adding up the number, you know, calculating the average CPU while the Lambda function, the handler itself, is doing the hashes. And then that would make it really easy to do this in any language. So what we need now is we need a Rust extension or a Go extension. I could do Go. Rust, we're going to suffer, chat. If we do Rust, we're going to suffer. We're going to suffer through it together. They do have one. They have a Lambda extension crate for Rust. Yeah, Lambda runtime, Lambda extension, here we go. But it just subscribes to events. Oh, and how much of this is gonna... I mean, hopefully this is super lightweight. We could do this. We could do this. I think that would work. Where would I start with this? I would have to... I think we have to do a few things. Even if we didn't do Rust, we need to start with extension tools that can actually like publish one of these things and make it into a layer. Because I don't think otherwise, like the other option is to like, I mean, maybe that is a better option, right? We just fork a process in Node and let Node hash some things and spy on the CPU there, because that would work. It just, then I would have to do that in every language, which is going to be maybe more work, probably the same amount of work as this. We got to think about that. All right, I want to see if they are going to give me 4 CPUs again. That was weird. And I wasn't even, I realized I wasn't on stream because I was showing you people my keyboard. That's fine though. We're very consistently getting like 28 hashes, which is kind of cool. Oh, never mind. There's 23. So maybe there's a little variance. With the extension, I think if we did the extension, the problem is that that's a separate process and we're going to introduce overhead context switching. Does that make sense? What if we push this somewhere else? What if we just like who cares? How many hashes per second we can do during the init phase or the real phase. So we proved that already. I think we've shown that Michael's research or Michael's blog post is still correct. But I wonder if we could show... I wonder if we just ate CPU and then we just kept in handler time during... Oh, because the extension would also get a init time. Sorry, I know I'm not explaining this super well. So Lambda extensions can run alongside the main process, right? And they actually can start before it. So like Lambda extension API. Let's talk through this quick. Okay, so this is a big, pretty picture. Give me this in a new tab. Okay. So Lambda service is in like the fabric or the control plane, talks to the runtime, and then we have potentially one or two extensions. And then the handler would be like even over here. So during init, the extension starts, we register, we call init, and then the runtime, like your handler, will init. So we should be able to spy on init, like the extension should already be running during init, and then we could capture that information. And then after the init's done, the function calls next. Do we call? Yeah, then we call next. So we should be able to delineate between the two. Once we call next, though, I think we stop running. Oh, this might be tricky. I think we stop running once we call next. So maybe an extension wouldn't work, right? Because as soon as we do that, the Lambda function will init. We're stopped. We can't read that file. Does Perplexity know about this? Node.js script, which... Yeah, Rafaz, exactly. It freezes the runtime. So I couldn't spy on... I can modify init, but I can't spy on the init of the function handler from the extension. So that wouldn't work. Process.cp, that's a thing? Does this exist? Oh, it does. Maybe we'll just use the library again. Oh, but it only tells me just like for all the CPUs. This won't work. Because I want to see it by core. Can we read the code for CPU usage? That's a real question. The process CPU usage metric returns the user and system time of the current process in an object with properties user and system whose values are the microsecond values millionth of a second. These values measure time spent in the system and user code respectively and may end up greater than the elapsed time if multiple CPU cores are performing the work. Oh, you can get a diff. That's kind of cool. Don't they have a link to the source normally? Oh, great. Accuracy. Node. Is there a process file? There. Oh, that's issues. Oh, they gotta be logged in. Sorry, should have done a warning for you folks, light mode folks. Here we go. Oh, this is just wrapping itself. Yeah. Sure enough, just wrapping itself. Okay. Hello and welcome to Hacking Node.js. That's fun. I mean, that's kind of neat, right? So we could do this. We could do like, we could do process.cpu usage const start equals, and then we can do calculate hashes. Oh, to import this. Why is this not running? Oh, day plus. Oopsies. And then we can do process dot. What do we call this? Start something? It's right on my screen. Oh, start. So that just tells me the time. It doesn't tell me idle or anything. It's not that helpful. Well, how is this implemented? That's what I want to find out. I know what it does. I want to find the source code. Oh, OSUtils does this? Oh, calculate CPU usage for the next second. That's cool. Maybe we can do this. We'll do like a method like this. Should we try this? Yeah. Or do we have to install it? What? Why are we going to install 200 lines of code? Okay, so they just wrap it in a set timeout. Is that even going to be right though? Because it's going to, I think the CPU will, the only thing it will be executing at this point will not be the hashing. It will be the reporting this information. Oh, os.load average. So we have this. That's something? Okay. What is that? One, 5, and 15. I'm learning so much about node internals. So I guess, what if we just did it? So we can't do it for a minute. That won't work. See, okay, now we got to figure out how this is implemented, because I want to grab like 6 seconds of it, right? The first 6 seconds. I don't want 15 minutes. GitHub Node.js. Oh, it's getting it from libuv. Okay. So it's like a runtime metric. I should ask about this at work. That'd be so much easier if I could just hook this straight up to pprof, actually. We can figure this out, chat. We can do this. I did promise we'd look at analytics from the last blog post, though, so we should probably do that first. We're kind of been on this for a bit. We'll dig through internal binding. Less. Schizophrenic web developer. Hello, welcome to chat. What are we doing today? So what I want to do, there's this blog post from a while back from Michael Hart about how you can save a bunch of money on Lambda by basically using the free init time, which gives you more CPU. So he wrote this little handler that calculates some hashes, and he wanted to compare init to the init time for a Lambda function to how much hashes you could compute inside of the handler. And so I recreated it, and it's very clear that you get more power, more vCPU power during initialization than you do during the regular handler runtime. So we've got, you can see we did 23 hashes in the 2 seconds that we used of init, and then in the same 2 seconds we were only able to do 2 hashes at a rate of like, I guess 0.8 per second. I set timeout, can't be perfect. So what I wanted to do is see a little, so we know we get more CPU, that's okay, but I want to see how much. And Amazon publishes that 1,769 megabytes is the limit you have, the threshold you have for the equivalent, what they say is the equivalent of 1 full vCPU. But I already see that there's like 2 cores on a Lambda function, even with 128 megabytes of RAM. But my guess is these are heavily throttled. So I want to see how much CPU usage, like what percentage we'll actually get out of our CPU while it's running these hashes. And then the idea of like, how do we both monitor CPU and hash stuff is a little tricky. A Lambda extension could work. It's just that gets kind of heavy because I can't just, I mean, I could just write the standard out. But I have to like kind of pull on that because these values for CPU info are live. It's not like an average. Node has this like look back mechanism, and that's what we're looking at is like, this gets some load average values that are written into this buffer, and it's reading from proc load average, I guess. But it's just slurping it up, and you get 1 minute, 5 minute, and 15 minute. So we can look at that. Cat proc load. Yeah, so that's, yeah. What does the proc load have? Linux proc load. Averaged over 1, 5, and 15 minutes. But I don't want that. Linux load average 10 seconds. Can I find that? I don't want a monitoring tool. I just want like a little tiny file. Oh yeah, load average is weighted moving average. So that's not really what we want. So basically we're just trying to figure out how much CPU power you get in Lambda, and then what is that? How does that map to cores? The number of cores and what percentage saturated are those cores inside of a Lambda function, like while it's running. It's kind of what I want to figure out. Thanks for stopping by, though. Hope you're enjoying the stream. So yeah, they call slurp, and I'm assuming it's namespace for some sort of security reason. I don't know what it does, but they're just reading that file. UV open col silo exec, and then do read. We can write some C today. It's been a minute. But that's fine. So it's just a Linux built-in. That's the answer. Load average is just a Linux built-in. What does OS machine do? Oh, just the architecture. So we had explored initially. We wrote our own os.cpu's output basically by doing the exact same thing that load average does, which is reading the actual file out of proc. And that was fine. We got that working. But then the real question is like, how do you do this concurrently? And the answer is that's really hard, because anytime we're going to do that on the same CPU, we're going to steal cycles away from the hashing process, which means we'll like artificially lower what you could do, which is normal for all monitoring products. I mean, everything we work on at Datadog is a similar trade-off. The more like if you're gonna spin CPU cycles looking at your CPU, you're gonna have less cycles to work with overall. So I guess that's probably pretty expected. But I still want to figure this out. And the goal, I guess, my goal, what I want to do, is have like this test bed system where I've got like a function running 128 meg, 256, kind of all the way up to the 10 gigabyte limit. And then I want to run those every few days and see if they change it, and see if you get more CPU or less CPU during the day or night, depending on the region. And then I want to see how that compares across runtimes, and then how that compares like container images. But for that to work, I need something that can sit, that can get the CPU information and forward it out, which Datadog does. And actually the Lambda Insights extension also does. However, it's a pretty heavy impact. Any extension is already a heavy impact because it's gonna create a separate process. So I was hoping to find a way to do this internally, if that makes sense. But I did promise we were gonna look at stats. So let's shift gears a little bit. If you're just joining the stream, I write a bunch of blog posts. I just published this one on the ultimate guide to secrets in Lambda. Why does it say my stream's offline? There, yeah. And this got some popularity, I would say, and I noticed a bunch of folks mentioning it on social media. So I want to see how we did on stats, and I want to compare. because I have two stats information, or two different analytics things running right now. I've got Google Analytics, and I have serverless web analytics, which is a cool open source project by another AWS hero. Yeah, so we'll plug Rahan's project here. Whoopsies, I don't care about this. So I think the reason I hosted this project myself, for a few reasons actually. It's a cool project by a friend, and second off, maybe the most important thing is that it runs on my own domain, so I can prevent people who are blocking third-party cookies like myself from basically like this analytic will still track, and I want to see the difference. But yeah, if you haven't read this post yet, you might be interested in seeing this. I wrote this over the last few weeks. It's all about how the various ways you can store secrets and use them in Lambda. Either you can put them in environment variables, parameter store has a standard and advanced parameter, secrets manager, or you can roll your own with KMS, KMS is pretty interesting. I've done that a few times. But let's take a look at Google Analytics. Okay, last 7 days, 1.9K sessions, 1.5K users, 2,000 people. That's not bad. It's like a week old. Let's look at the last 14 days. Yeah, so we published the blog post on the 27th. So we got about 3,000 hits. It looks like the blog post got 2,000 views, 2,078 views. I'll take that. That's not bad at all. A lot of unassigned referrals, direct, social, organic. Now, let's look at... Oops, 1 second. Okay. What's the last 14 days here? It's going to be boom to boom. Okay. So this says we have 4.7 thousand views. And it says the secrets guy got 3.1 thousand views, 3,063 hits compared to 2,100. So that's interesting. Actually, almost a full third of people are using AdBlock probably, which I guess makes sense. I mean, I am. I don't get any hits for my own post. That's pretty cool. So that was basically really why I wanted to host this here, because I wanted to be able to see for the folks that are using AdBlock, what does that look like with a first party cookie. And it doesn't, you can see this I don't really get that much out of this tool in terms of like the creepy analytics. I get a referral, which is cool. Oh, we should look through these. cloudseclist.com, Substack, TLDR DevOps, TLDR Sec, TLDR InfoSec. What are all the... Oh, they must be newsletters. I got mentioned, I think, a couple people tagged me on Twitter in this. And then I get to see, like, who referred me or who was a referral. Memento. Thanks, folks. Shout out Memento. Gotta respect the sweater. Whoopsies, what did I click? Oh, Serverless Guru. Let's filter just to the guide, since that was our latest post. 3.1K views, 2.3K visitors. Not bad. Is TLDR Sec and TLDR InfoSec different? Cloudseclist.com. What is that? Oh, wow. Do they have their... Oh, here we go. Past issues. Oh, Marco Lencia. Oh, that's nice. There we go. There's the feature. Okay. So that was one of them. What was the other one? The big one. TLDR InfoSec was another big one. Is it .com? No. Oh, I think this is... Okay, is this Clint's newsletter thing? Okay, yeah, so that must have been it. Cool. All right, I'll take that. That's sweet. I got tagged on something. Yeah, I got here. Someone tagged me on this one. TLDRSec 225. Can you read the whole thing here? Yeah. Here it is. Okay. Aegis Armor has pulled together a definitive resource on how to handle secrets with Aegis Lambda, looking at 4 different services, compares them across ease of use, auditability, rotation, collecting capability. In short, secure strings and parameter store, unless you do rotation or regulation, and secrets manager. Okay, that's all right. I mean, sort of. I guess I was a little bit more in depth than that. I need to also discover some stuff and write a blog about it. Yeah, I mean, that... writing has been really big and good for my career overall. I think it's really improved my ability to communicate with teammates and coworkers and, you know, executives and stuff, and also just other people. And the more I hack around Lambda in the way that you saw today, like that is where my like best blog posts have come from, you know. I think if you really zoom out, I've had probably, well, I've been fortunate. I've had a number of popular blog posts, but one sec, sorry. I definitely recommend it. Start a blog, write about stuff, write about things you learn. I want to finish this. Hold on, real quick. Use KMS if you have a compelling reason. Comment being cost of scale. I should note, though, I don't think his cavalier attitude to secrets and Lambda environment variables is necessarily good general guidance. Okay. I wouldn't say I was cavalier. I think I'm pretty balanced here. Most people say this is in plain text. That's not true. Lambda environment variables are encrypted at rest. So I don't think that's that cavalier. They're encrypted. They're decrypted when the function initializes or when you take any action to get function configuration. That includes looking at the environment variables section of a Lambda page. So yeah, that like you're decrypting your secrets then if you use them. I would push back on the notion that I was cavalier. I think I was just pretty pretty even keeled here, but there are risks to it, a lot of risks, including, you know, blowing a secret wide open on a Twitch stream. But there are options. There are a ton of options. And like I said, like, there's this pattern for using dynamic references in your CloudFormation stacks to pass a reference of your secret to CloudFormation so that CloudFormation won't keep your environment variable plain text in your CloudFormation stack history. It's still, like, I should be totally clear. Anything you consider secret that you really cannot leak, you can't keep an environment variable. That is just not acceptable. I did say, like, if you have like some sort of third-party telemetry API key, like an Elk stack, you can just create unlimited keys, and you can create one per function if you want. So it's like and they're usually write-only keys. So writing to, I don't know, your telemetry service may not be that big of a leak. Maybe that's a little cavalier, I guess. I don't know. I'm just happy they shared it. Yeah, the blog stuff though, web developer, these are like all the posts I've really ever written. I think I've taken a few down. It's not that much. Like I wrote about a project I did a long time ago for importing a bunch of users in like a few minutes. That worked. Rails 5, when that first came out, I talked about, we did like a bunch of custom migrations, and that didn't work anymore. So I wrote about that. I did some serverless writing. Like these are just like little projects for a while, and then it just slowly built up, right? I like this post. If you haven't worked with zip files at a file system level before, you may not know this, but the zip archive, there's nothing in a zip file structure that says you can't have two files with the same name in the same directory. That can't exist on a ext4 file system or most file systems you and I run on our machines, but that's totally fine in a zip archive. That's entirely okay. So depending on what version is on your machine or someone else's machine, they handle this differently. Sometimes it's like last write wins. Sometimes it will ask you all these types of things. There's like that was an interesting bug I ran into, and then I wrote about it. And that's where it really started. And it kind of just grew from there. These are opinion pieces developing against the cloud and serverless at team scale. Talking about mono Lambda versus single function APIs. This one was pretty popular. I think the most popular one I've had, actually I get referrals for function URLs all the time. But benchmarking the AWS SDK was extremely popular. Streaming response was extremely popular. Proactive initialization, this is probably the most popular post I've ever written. Lambda layers did okay. Containers on Lambda also was very, very popular. Let's just look, right? We can look. This is last, whatever. Let's look at the last 12 months. Yeah, so I've had like kind of 3 big spikes. This is from Secrets. This is from the Containers in Lambda paper that I wrote about. And this is from proactive initialization. And it's like a 1-day spike or like a 1-week spike or whatever it is at this view. So yeah, you can see this like last 12 months. Yeah, so I think... Oh, that's 28 days. I want last 12 months. Wow, way to go, Google Analytics 4. Yeah, okay, so here you go. So proactive init was very popular. Containers on Lambda, very popular. And then Lambda layer, like everything else is kind of after that. So they're not all bangers. I'd like to think they are, but they're not all bangers. But just do a little writing, you know? It's definitely worth it. Like, write about these things you find. I'm sure I'll write more about the CPU stuff as I work through it. This is going to be a longer project, as you can see already. Like, it took us, we're nearly 2 hours here, and we're basically able to print out the CPU information and then do some hashing. But the trick will certainly be figuring out how to do this at, I don't want to say at scale, but like while the computer is doing useful work. And what I want to figure out is, my guess is there's still going to be a bunch of idle time, because I believe the way they implement CPU scheduling is with that like token-based system. So you get, the idea is you have this cup of tokens, and every millisecond they put a token into it. And if the cup is completely full, you drop the token and it spills out. And then anytime you want to use all those tokens, you can turn it over and use it, but then they only drop at the same rate, like 1 token a millisecond or whatever, in an abstract concept. So hashing will burn through those tokens. It will burn through your burst. And then I want to just see inside of Lambda what percentage of that CPU is like active. Like, does it go over 100%? Does it burst? Does it stay up to 100% for one vCPU? Is that how that works? Or do they like throttle you down? And my guess is they throttle, because I think the easiest way to do this, if I were designing Lambda, is to have Firecracker expose with each task a certain amount of CPU and then throttle it if I want to get more incremental steps. That'd be my guess. That's my guess what they do. Because at a certain point, it's not like you have one like even band of CPU over the whole 0 or 128 megabytes all the way to 10 gigabytes you can get in Lambda. There's definitely some step to it. And that's kind of what I want to figure out. And I basically want to be able to generate that, plot it, and then tell you the difference between that and then the initialization as well. Because I think below 1 gig, the init phase gets a lot more RAM. And then I want that to be live. I want it to be updating in the same way Max's cold start is live. And I think this is this is an amazing project. It's a very popular project. Gets referenced, I'm sure, inside of AWS and also externally all the time. But I kind of want to do something similar, but for CPU. That's kind of where I'm at. But anyway, it has been close to 2 hours. I'm going to have to go and walk the dog. I do appreciate everyone stopping by. Thanks so much. For those of you watching on Twitch, we're going to start a raid. Let's go and hang out with the Alt F4 stream there on the top of my list today. I do appreciate everyone stopping by. Thanks. Spending part of your weekend with me. We'll get back to this project again, probably tomorrow or for sure next week. Peace, and if you're going to watch the eclipse this weekend, enjoy. See y'all.